everyone, welcome back to Mathematics class. Today we will continue about polynomial and remainder theorem. Now we will discuss what is remainder theorem. The learning outcome for today's session is you will be able to mention and explain the effectiveness of remainder theorem in finding the remainder of polynomial division. And also later you can describe the condition which remainder theorem cannot be used, and we need to use other way instead. First, let's recap in previous lesson. You already learned about long division of polynomial to find the quotient and also the remainder. But what if we need only the remainder? So, we surely won't find the remainder using long divisions since it spends more time and efforts, and also including the error factor made along the calculation. So let us now consider a simpler way to obtain the remainder if a polynomial is divided by a linear divisor. First of all, we will do the identity. For example, if the dividend is 2x to the power of 4 minus 3x cubed plus x squared plus 1. The divisor is here, x minus 2, and this is a linear divisor. When you make the identity, dividend is divisor multiply with the quotient added with the remainder. And since the divisor is linear, you can find the constant of remainder. Now, if we suppose that fx is 2x to the power of 4 minus 3x cubed plus x squared plus 1, then now we will simplify this, become fx equals x minus 2 times qx plus 13. Let's see that when you substitute x value with 2, then at the left side you will have the value of the function of f2. At the right side, when x is substituted by 2, you will have 2 minus 2 times q. When you multiply, this will be 0. This part will be 0, and we'll only have a constant of 13 at the right side. So, if you see this 13, this is the remainder. We can conclude that the remainder can be obtained by substituting the polynomial by the zeros of the divisor. Let's see here, if the divisor is x minus a, then the remainder will be fa. Let's prove it here. So, when you have fx equals x minus a times qx plus r, suppose we don't know the remainder yet, so when you substitute this term by a, you can have 0 multiplied with the qx. So, this part of multiplication become 0. Then, when x is a, fa, the value of the function at x equals a will be equals r. R is the remainder. So, for any linear divisor, you can have the value of the remainder by simply substituting x value by the zeros of the divisor. Similarly, for the divisor ax minus b, what you substitute will be the zeros of ax minus b. Ax minus b equals 0 when x equals b over a. So, when ax minus b becomes 0, 0 times qx will be also 0, then fb over a will be equals to r. And this is our remainder. Let's see example 1. Find the remainder when a function is divided by x plus 3. So in here, since we only need the remainder, we will try to do it using the remainder theorem. Let's see fx, which is 4x cubed minus 5x plus 1, divided by dx, which is x plus 3. So we will write this identity using fx equals dx times qx plus r. In here, we will try to make this part equal 0 by substituting x equals -3. -3 is the zeros of this divisor. So at the left, x value is substituted with 3. So you have 4 times -3 cubed minus 5 times -3 plus 1. And at the right side, you have 0 times qx plus r. Then, at the left side, the value become -92. And at the right side, you will have r. So r will be -92. And this is our remainder. Next, let's see. In here, when the divisor is linear, the remainder can be found by simply using the remainder theorem instead of the tedious process of long division. So what if it is nonlinear? And also, what if the problem also asks the quotient? For the first problem, we'll discuss it after this. And for the second one, of course, you have to go back to the 3 methods of division of the polynomial. Let's see example 3. When the expression 2x to the power of 4 plus px cubed plus 5x squared plus 7 is divided by x plus 1, x minus 2, the remainder is qx plus 18. This result may be expressed as, this one is the identity, yeah? fx equals dx times qx plus rx, where qx is the quotient. By substituting suitable values of x, find the values of p and q. We can see here that the divisor is not linear. And of course, the remainder become a linear remainder. So, to find out two unknown p and q, we will use two simultaneous equations. What x should be substituted here? Let's find it out. First, for the fx equals dx times qx plus r, we can substitute two values. For the first one is the zeros of x plus 1. In here, we substitute x equals -1. And for the second divisor x -2, we will substitute x equals 2. Then, there will be two simultaneous equations to find out the two variables p and q. Let's see how to solve it using substitution and elimination method. So, we substitute x equals -1 here, and this is the first equation. Minus p plus q is 4. And for the second equation, when you substitute x equals 2, then you will have f2, which is simplified, become 6q equals -9. So that q is obtained here -1.5. We substitute it to the first equation to obtain p. So we found p is -5.5. Okay, so this is the conclusion of the remainder theorem. Remainder theorem is used only to obtain the remainder. And then, if a polynomial fx is divided by x minus a, then this is the remainder theorem. Remainder is fa. If the divisor is ax minus b, then the remainder become f b over a. When you have quadratic divisor, then your remainder can be obtained by solving two simultaneous equations formed by fa. This is substituting x equals a for the first divisor, and fb, which is substituting x equals b to the identity. Okay, so that's all for today. Let's discuss it again at our meeting. Stay healthy, everyone. God bless you all. Bye-bye.